Hi guys, so today we're learning about square root graphs. So these are sometimes called radical graphs as well, but we're just going to start by graphing some of the points. So in this case, we're asking us to graph y equals the square root of x. So normally I would just like choose some x's, but since I want to do the square root of x, I want to choose numbers that are going to be easy to take the square root of. Like I can take the square root of 0, I could take the square root of 1, but taking the square root of 2 would be like a decimal number. So I don't want to do 2 or 3, but 4, the square root of 4 is 2. So 4 is a good number. 5 doesn't really work. Square root of 6 is a decimal. Square root of 7, square root of 8, square root of 9, right? So square root of 9 would be 3, kind of like that. And then, as you guys might guess, if this one's 4, then what number do I take the square root of to get 4? It would do 16. So the square root of 0 would be 0, and then the square root of 1 would be 1. So if I'm looking at like how to graph them, remember this is like 0, comma 0, like that. So I would say, okay, that point starts here, and then 1, comma 1, and then 4, comma 2, so that'd be up here, and 9, comma 3, right? So that'd be over there. So then I would draw this graph like this. I can't put this last point on because it's not, like I don't have enough x values on my x-axis. So the shape of a graph, of a radical graph, always looks like this, right? Sometimes it might be upside down, oops. Sometimes it might be upside down like this, like that kind of. Sometimes it might be backwards like this. But it always kind of looks like this graph. It kind of reminds me of like the actual like square root itself. So if that helps you, it helps you to like think about like, oh, we're making this shape with our graph. Miss Name calls it the shooting star graph. So next year you'll hear that. It's the shooting star, right? So it starts at the origin and then it goes out. So then our next question says, where is the beginning point? Also known as a critical point. Right, so the critical point is like the center of the graph. It's the point where it starts. And in this case, the critical point is right here in the center. So the critical point here would be 0, comma 0. Something like that. So it starts at the origin in this case. And we'll see that the shooting star graph or the radical graph can move around the graph based on different places, different things in the graph or in the equation. So this is like the normal equation. We've dealt with these before. And it works in basically the same way. So what we have here is our H is our left and right movement, and K is our up and down movement, and A, as you guys might remember, is like stretching or shrinking or flipping upside down, right? If they put a negative there, it's going to flip upside down, that kind of thing. But the ones that we're going to focus on for the critical point today are H and K. Because the critical point, which we're going to call CP, critical point, right? The critical point is located at H, comma, K. So for example, if I had the equation like y equals square root of x plus 2 minus 4, right? Then what I would do is I would say, okay, the H is negative 2. And the reason it's negative 2 is because, see how this equation here has a minus in it? All right, so technically what I'm saying here is x minus minus 2. That's how we're getting the plus sign there. All right, so what you really need to remember is that if it's next to the x, right, just like if it was in parentheses, we need to do the opposite. We're going to flip it. So if this is a positive 2, that would become negative 2. And then the second one, the one that's outside of the square root, is going to stay exactly the same. So it would be negative 4, like that. All right, so the critical point, the center of where this graph starts, is that would be at negative 2, comma negative 4. So we're going to look at some examples for critical points. Something that we want to sum up here is it says the number inside the square root with the x is the opposite or flipped, whichever word you want to use there. And then outside the square root is the same. You keep it exactly the same. So what I mean by that is if I'm looking at this one here, this one is inside the square root. The plus 2 is inside the square root. So we're going to change it into -2 when it becomes our x value for our critical point. Right? And then there's nothing out here, right? It's like kind of like empty there. So it's kind of like +0. So I'm going to put a 0 here. So as we can see in our graph, our critical point is at -2, 0. This point right here, that's where our shooting star graph starts. And then it goes up like this. Right? From there, we might see a graph that looks like this. So we see that there's nothing inside with x, so it's kind of like +0. So I'm going to put a 0 right here. And then this is -1, so -1 goes straight here. Because remember, if it's outside the square root, it stays the same. So since this one's outside, it stays the same at -1. And we can see that happening here. 0, -1 is where our graph starts. And that's where our shooting star takes off. So for this next one, we see this minus out in front, right? The minus outside up front is going to make it flip over, which we can see in our graph. It's upside down. It's kind of like a, I don't know, not a shooting star. And then for these ones here, I have an x inside the house. So +2 is going to change into -2. And then -1 stays the same, so -1. So my critical point, my center of my graph, is going to be at -2, -1. So we can see that happening right here. Then finally, maybe take a second to try to pause your video and try this one on your own. And come back. Cool, so for this one, the 2 is going to make it taller. We're not super worried about that right now, but we can see that the graph is a little bit taller here. And then next to the x is a -3, so we're going to change that into +3 for our critical point. And then -1 is outside, so it stays the same. So I'm going to write -1 here. So our critical point, our center should be at 3, -1, which we can check over 3 down 1. Perfect, it's at -1. So today we're going to focus on the critical point and then converting from the equation to the graph, from the graph to the equation. So check it out.